Hey guys, here we are in chapter 3, lesson 3. We're talking about equations in y equals mx form right here. Equations that are written like that are both linear, which means they make a straight line, and they are proportional, which means if you graphed it, they would go through the origin. Okay, so a new word, if it's proportional, which is what we're going to be talking about in this lesson quite a bit, it's also known as a direct variation. And then your constant ratio, your y over x, your, in this case, $20 over 2 hours, or $40 over 4 hours, or $60 over 6 hours, all equal $10 per hour. That is your constant ratio. It's your constant of variation or your constant of proportionality, which means if I were to write an equation, it would look like this. It would be y equals $10 per hour. X is hours right here. Y is how much money you make. So your money you make is $10 times the number of hours. And that's the formula we're going to use all day. Okay, so let's look at it on a graph. Lesson slide number 2. Obviously, the amount of money Robin earns while babysitting varies directly with time shown in the graph. So money varies directly with time. Makes sense. More money, more time she works, the more money she makes. Okay, so if we look at the graph, we notice not only it's linear, but it also is proportional because it goes through the origin. And it just asks us a simple question. Robin earns per hour. What does she earn per hour? Well, I'd find a point, a really good one, like right here. In 2 hours, she had $15. And here's another one, 4 hours, $13. And it should be the same, no matter, $30. And it is the same no matter what, 15 divided by 2 or 30 divided by 4. And she is going to make $7.50 per hour. That is her rate. Now, if I were to write a direct variation equation, it would be the money she makes is $7.50 times the number of hours, because X is hours and Y is money she earns. Okay, so that's in a graph, and we looked at a table in our first slide. Our third slide, we're going to look at what a direct variation looks like just in a word problem, which sometimes it seems more difficult, but it's just the same. Okay, number 1 in slide 3 says a color printer can print 36 pages in 3 minutes and 108 pages in 9 minutes. And check this out, it flat out tells you number of pages varies directly with time. So to find your constant, it is pages over time. Okay, pages is Y, time is X. And so they gave us 2. They said 36 pages in 3 minutes or 108 pages in 9 minutes. Either one you use, you will get the same answer. It is 12 pages per minute. And that is pretty zippy for a colored printer. Okay, that's the rate. They didn't ask for it, but if we wrote an equation, it would look like this. Pretty simple, because 12 is our constant. Okay, look at A. 2 minutes after a skydiver opens up his parachute, he has descended 1,900 feet, and after 5 minutes, he descended 4,750 feet. The distance varies directly with time, so our constant is going to be found by putting the distance over time. And they gave us 2 options again. We can take 1,900 feet after, 2 minutes, or 4,750 feet after 5 minutes. You guys can divide those out, but either way, you are going to find it is 950 feet per minute. That's how far he is descending and how quickly. Okay, so we've seen it in a table, we've seen it on a graph, line that goes through an origin, and we've seen it in words. So right here are the 4 ways we can represent a direct variation. With a table, notice this one has a constant variation, 3 over 15, 4 over 20, 5 over 25, and 6 over 30. Those all equal 1/5. We can show it with a graph and a straight line that goes through the origin. We can write it in words, or you can write an equation. Those are the 4 different ways. If you flip your paper over, you're going to see they're going to ask you to compare them. So how do we know something is a direct variation? It has to be proportional. In other words, it goes through the origin and it's a straight line, which means the constant rate of change and the constant ratio must be the same. So take a look at this example. Mike spent the amount of money shown tokens at playtime games. So I'm going to look here. I'm going to divide. Okay, well, $3 divided by 15. 1080 divided by 54 tokens. 25 tokens. Oh, goodness. $5 divided by 25 tokens, and $720 divided by 36 tokens. If you divide any one of those out, they will tell you that it is going to be 20 cents per token. Okay, we found out it's a direct variation. We found the constant ratio from the table. That's for playtime games. And then tokens at game time are 25 cents per token. And they just flat out tell you. So which arcade has the better price? Playtime's games is only 20 cents and the other one's 25. So we're taking 2 different direct variations in different models, one in a table, one with words, and we're comparing them. Let's look over here on slide number 6. We're talking about Damon. Damon earnings for 4 weeks from his part-time job are shown in the table. Assume his earnings vary directly with the number of hours worked. He gets paid hourly. So if we divide that out, if he worked 15 hours, he gets $112.50. 12 hours gets him $90, and so on and so forth. So how much money does he make per hour? Well, you're going to have to divide that out. Hopefully I can do that here real quick. So he's making $7.50 per hour for that one. Now, he can take a job that's going to pay him $7.35 per hour. So in this direct variation, they just told us what his rate was, what his ratio was. Which job has better pay? The job he is currently at pays more. $7.50 compared to only $7.35 per hour. So he should stay at the job he's at. All right. Take a look at slide number 7. A 3-year-old dog is often considered to be 21 years in human years. We talk about that. 7 years for every dog year, because they don't live as long. So assume that the equivalent age in human years varies directly with his age as a dog. So that would mean 21 over 3. In other words, 7. So write a direct variation. You guys could have done this problem without writing a direct variation. You simply take 6 times 7. But half of this lesson is going to be writing the direct variation. We found that 21 over 3 was 7, so that is our m. So our equation is y equals 7 times x. That's our equation. And then we plug in 6 equals 42 years. So the dog is 42 years in human years. Okay, let's try number 4. A certain store, 4 cans of soup cost $5. Assume that the cost is directly proportional to the number of cans. So they even tell you cost is y, cans is x. So if it's $5 for 4 cans, I'm pretty sure that's $1.25 per can. So write an equation. Cost equals $1.25 per can. There's our equation. Now plug in 10. So what's 125 times 10? Should be $12.50. There you go, writing the equation. Okay, well, what happens when it's not a word problem and they give it to you just like this? They want you to first write an equation, then find a value. So if y is negative 12 when x is y, right there, they're giving you the constant, y over x, which is going to be negative 4 over 3. So your equation, y equals negative 4 over 3x. Now it says find y when x is 4. That seems pretty simple. Find y, when x is 4. Just multiply it, and you know what? I'm going to leave it, negative 16 over 3. No need to reduce it. I'll leave it right there like that. Okay, take a look at this next one. If y equals negative 6 when x is negative 14. So here's our example. Find our constant. Negative 6 over negative 14. Well, it's going to be positive. And then I take out a 2, I get 3 over 7. So y equals 3 over 7x. Find x when y is negative 4. So find x. So we're going to put negative 4 in for y, because that's what they gave us, equals 3 over 7x. Solve for x by multiplying by the reciprocal. And again, not going to be very pretty. Negative 28 over 3. And I'm cool with just leaving it like that. Okay, on to the next page. We're just going to do one more for today. Then we're going to move on. And you're going to get your worksheet out. Okay, a charter bus travels 210 miles in 3.5 hours. Assume the distance traveled is directly proportional to time. So our constant is found by distance over time. In other words, 210 miles over 3.5 hours. So how fast, what's our constant rate of change? 210 divided by 3.5. And guess what? It's a decent speed, 60 miles an hour. So our equation, y equals 60 miles per hour, x being time. And then find how far they will go in 6 hours, which is 60 times 6, 360 miles. Okay, so you have your first day worksheet. That's the one you're going to complete right now. Please be careful, read carefully, and we'll continue with the second half of the lesson on the next one. Good luck.